Good evening friends. In this video we will talk about what if the data set is imbalanced. So we have usually face the problem of imbalanced data set. So we will discuss what is the impact of the data set on the model and what will be the impact of hyperparameters on the data set of the different ratios. So first we will observe actually the how hyperplane is changing according to the change in the learning rate. That means if we change the hyperparameter, then how will it impact the our hyperplane of the lean SVM actually. Okay, so below if we have created four random below we have created four random data set which are nearly separate linearly separable and having the class imbalance. So we have created four data set of different data ratios. The ratios are 10:2. Okay, the second ratio is 10:20, the third ratio is 10:40, and fourth ratio is 100:80. So let's see how it's look like and what will be the impact of it. Okay, so we are applying this dataset on linear SVM support vector machine. So let's see it. Okay, this is the first figure where the data ratio, this is the first set of dataset where we have the ratio of 100:2. So we will see what is the impact of different C value of C on the hyperplane. So this is our dataset at 0 and this is our hyperplane at approx 15,000. So here the value of C is 0.001, that is 10 to the power minus 3, and the ratio is 100:2. So this is very far away. Our hyperplane is very far away from the separating the data sets. Now moving to the next figure, we have this increase the value of C from 10 to the power minus 3 to 10 to the power 0. So what will on the same data set, so what will impact? It has came near to 9. So that's a huge difference. There's a huge difference. So it's getting better after we increasing the value of C. Now see what if we increase it to 10 to the power 2. So it is separating the red dots with the blue dots. Since we have only two red dots in our data set, but still it's separating one of the red dots and one is on the hyperplane. So it has done well, but since it's not good because we don't have such amount of human such amount of data set to verify it, so we can't rely on this model. Okay, now moving the next set of data where we have the ratio of 100:20. Okay, it means we have 100 blue points and 20 red points. Now if the value of C is equal to 10 to the power minus 3, then the hyperplane is at 600 and our data set is at 0. So it's also not separating the hyperplane, but it's doing better. It has done better from the previous model, this model. Okay, now if we increase the value of C from 10 to the power minus 3 to 10 to the power 0, it has came near to the data set, but it's not separating. So it's not that good, but yeah, it is increasing. So increasing the C value of C, it is we are increasing the decreasing the regularization actually. Okay, now sorry, I'm really sorry. Now moving to our next set of data, next value of C, that is 10 to the power 2 with the same data ratio, that is 10:20. So it's, you can see that it is very separating very well. It has done a very good job. So it has a good distance between their support vectors actually also. So it is doing very well on our data set and at this value. Okay, now moving the next set of data where we will have the ratio of 10:14. Okay, we have 100 blue points and 40 red points. Now our hyperplane is at 250, but previously it was at 600. So it is doing better than the previous one, but it's not doing well. Okay, now moving to the next set actually, where we have this value of c is equal to 1 and the ratio is same, 10 is to 40. Okay, it is separating half of the red points to the other side of the plane and half of the red points on the another side of the plane, but it's not doing good. We can't rely on this kind of model, so but it's doing better than this one. So increasing the value of c, it's doing well. Okay, now moving to the next set, where we have the value of c is equal to 100. Okay, where we have 100 points, blue points, and 40 red points. So the value of c is doing good. Okay, this hyperplane is separating them very well, but still there is a point in between this, so this can't be separated. If we separate this one, then it will be a case of totally overfit. So we can say that this model is doing very well on this dataset. Okay, now moving to our last dataset, where we have a value of where we have the ratio, dataset ratio 100 is to 80. Okay, now again we have starting from the value of c is equal to 0.001, that is 10 to the power minus 3, with our hyperplane is at 100. We can see that previously it was on a 250. Okay, so it is doing better than the previous one. Okay, it is doing better than the previous one, but still it's not good, because we can't separate the red ones with the dot ones. Okay, now moving to the next set, it has the value of c is equal to 1. Here we can see that it is separating blue and the red ones, but still there are 3 dots which are on the hyperplane, so it's better than the all previous one, but that's not so good. Now let's move to the another set. Let's see what happened. So here we have the value of c is equal to 100 and the same ratio. Here we can see that there are 4 points on the side of red ones, 4 blue are on the side of red ones, but you can see clearly that if we plot the hyperplane like this one, so it will be case of totally overfit, because we have so much of gap here in it. Okay, so our hyperparameter our support vectors have done a good job by separating this and not overfitting this model. So we are doing great with c is equal to 100 and 10 to the power 10 is to 80 ratio dataset. Okay, so what is the conclusion? Conclusion is the higher value of c leads to the less regularization actually, and with the higher value or data ratio, we will do much better. We can clearly see the difference. Here we also you can see the difference. Here we can also see the difference. Here we can also see the difference. So thank you.